Hello. In the last video we integrated the sine of the square root of x, and at the end of the video we figured out, shouldn't we always be able to integrate functions of the form f of square root of x as long as we can just integrate the outer function f twice? And in this video I will give you an intuition how to derive the formula, and at the end of the video I will give a proof for the formula. More precisely, the intuition actually turns into a proof. I mean, integral formulas are very easy to prove. All you have to do is you have to take the derivative of the result and show that you get the integrand at the end, right? So let us try and figure this out. The intuition, what we did first in order to get a formula for this integral is we tried to just integrate the outer function f once. If we do that and we take the derivative of the result, then we will get f of square root of x, which is good, but because of the chain rule we will have to multiply by the derivative of the inner function. So let us try exactly this. We will integrate the outer function f first. Let capital F be an antiderivative of f. Then capital F of square root of x prime is f of square root of x, which is exactly what we want. But as I've said, because of the chain rule, we will have to multiply it by the derivative of the inner function. That's the derivative of square root of x, and that is just 1 divided by 2 square root of x. So how do we get rid of this error term, of this 1 divided by 2 square root of x? Well, one standard idea would be to just try and multiply this by 2 square root of x. We try to cancel the factor of 1 divided by 2 square root of x by multiplying with 2 square root of x. But of course, this normally wouldn't work, because the result will have to be differentiated with the product rule, and that will give us a new error term that we will have to remove. However, we will see that this is a very easy to remove term. So we choose the function 2 square root of x times capital F of square root of x, and we take the derivative of it. So by the product rule, we leave the 2 square root of x and then multiply it by the derivative of this capital F of square root of x. But that's written up here already. The derivative of capital F of square root of x is just f of square root of x divided by 2 square root of x. And if you multiply it by this 2 square root of x, you will end up with just f of square root of x, which is exactly what we want. But we will get a new summand because we will have to add the other term of the product rule. This time we leave the capital F of square root of x as it is, and we take the derivative of the 2 square root of x. And the derivative of 2 square root of x is of course just 1 divided by square root of x. So we end up with a plus capital F of square root of x divided by square root of x. And you might already see that this is incredibly easy to remove, because we have a composition of function, capital F of square root of x, and then we really just have it basically multiplied by the derivative of the inner function square root of x, right? Because we basically just do times 1 divided by square root of x. And this basically looks just like the derivative of a function where the chain rule has been applied. So let's sum this up again. We see that f of capital F of square root of x divided by 2 square root of x is just capital F of square root of x times 1 divided by 2 square root of x. I changed the division sign into a multiplication sign so that we really can see that we multiply by the derivative of the inner function here. This is just capital F of square root of x times the derivative of the inner function square root of x. And again, this term here on the right side just looks as if the chain rule has been applied to something. So again, in text form, I summed this up. This is the composition of the functions multiplied by the derivative of the inner function, and that looks like the chain rule of differentiating has been applied. And now we get a little bit more precise. We now take capital G, which is an antiderivative of capital F. That's what I said with we are able to integrate f of square root of x if we are able to integrate the outer function f twice. We integrated it once to get capital F, and then we integrate capital F to get capital G. And then what we will of course see if we take 2 times capital G square root of x and we take the derivative of this, then we are just we do just end up with capital F of square root of x divided by square root of x. Or in other words, the integral of capital F of square root of x divided by square root of x dx is just 2 capital G of square root of x. And with that being said, we can easily remove this error term here, this capital F of square root of x divided by square root of x, by just subtracting this thing here, because basically the idea is that we add a function to this 2 square root of x times capital F of square root of x, which upon differentiating will yield a minus f minus capital F of square root of x divided by square root of x, so that we remove this plus capital F of square root of x divided by square root of x. So let us do exactly what I said. In total, we get that the derivative of now, we choose 2 square root of x times capital F of square root of x minus 2 capital G of square root of x. And if we take the derivative of this new function that we tried out, we get, well, we've already taken the derivative of this left term down here. We get f of square root of x plus capital F of square root of x divided by square root of x. And if we then take the derivative of minus 2g square root of x, then we are left with capital F of square root of x divided by square root of x times minus 1, because of the minus sign here. So we get so this minus 2g square root of x after differentiating will turn into a minus capital F of square root of x divided by square root of x, which will cancel with this capital F of square root of x divided by square root of x, and we are left with f of square root of x. And that is basically the proof that I already mentioned. This last line here proves our formula that the integral of f of the square root of x dx is 2 square root of x times capital F of square root of x minus 2 capital G of square root of x, where capital F is an antiderivative for f and capital G is an antiderivative of capital F. So that's what I've said in the beginning. All we have to do is integrate the outer function f twice and then plug it into this formula in order to integrate f of square root of x. So whether this is useful or not depends on how easy f is to integrate twice, and in some cases this is really fast. For example, with this formula we can very quickly integrate sine of square root of x, cosine of square root of x, and e to the square root of x. And then there are some cases where this method works but might be slower than doing a normal substitution. I think examples of this would include the arcsine of square root of x and the arctan of square root of x and the arc cosine of square root of x. The formula should be applicable here. You should be able to integrate arcsine, arc cosine, and arctangent twice, but it takes some time, I think. Or there are special cases where this formula is pretty useful, I think, and one of those would be square root of x times cosine of square root of x, I think. So yeah, that's the formula. That's a method of doing this without substitution. Or in particular, if you actually integrate this thing here just with substitution, then you will then you can still plug my formula and you will get that your result is the same thing as this thing to the right here, plus a constant maybe. And in particular, this might tell you something about capital F and capital G, in case you don't actually know capital F and capital G, right? In case you actually find it too hard to integrate the outer function f, or the outer to just integrate the outer function f, let alone integrate it twice. However, in most cases that really should be no problem. So yeah, that's the formula, and in the next videos we will try to apply this formula. I hope you've seen something new here, and I will see you guys in the next video.